Hello, welcome, glad to have you here. Guys, today I want to kind of be a skeptic. I want to take a look at MongoDB, a very popular NoSQL database, but be skeptical about it. So is it really as great as they say it is? Well, to answer that question, to have the answer for that question, we will need to actually take a look at the distributed systems, CAP theorem, NoSQL, and of course Mongo, promise and delivery. So my name is Tomasz Borek. I'm a Java Academy program head and leader since 2016. I have certified myself from Mongo back in 2012 because, Mongo was absolutely shining and cool back then. So as you can see, I'm not totally immune to the hype. Well, where this talk came from. So new Mongo releases sparked another wave of interests, inquiries. Number of my customers approached me. Tomek, would you say that actually, Mongo will be a good fit? I have this application. I'm thinking NoSQL. Is Mongo, a good choice? So I did some research, and hence here we are. TLDR. Mongo is nice, has nice documentation, and I do mean nice. Small projects will like it. Larger projects or projects which actually, skimmed on research, they may find themselves scrambling for PostgreSQL later on. This seems to be a trend in some circles. Mongo's marketing, don't make any mistake, they are very persuasive people. They are very dedicated to their craft, and the marketing message is quite powerful. Do your own legwork, employ Jepsen, study its analysis, or you and your projects may suffer. So let's begin. Is Mongo really popular? Well, let's take a look at what Google says. The first results that Google gives us is obviously the MongoDB website. And as you can see, they claim they are the most popular, not just popular, the most popular database for modern apps. I don't know if you heard about MEAN. MEAN stands for Mongo, Express, Angular, and Node. Even back in 2014, Free Code Camp had a blog post which said that real reason to learn MEAN stack with Mongo in it was employability. So Mongo very early managed to secure their position as a ticket to employment in IT industry. And also, well, you may say I'm reading too much into one blog post, but don't make mistakes. This is just a symptom. This is just one example among the many. MEAN was very also powerfully employed during hackathons because you had a quick tech stack to deliver. So there was that. As far as languages go, there are drivers for multiple languages. So you can integrate your programs with MongoDB if you write in Python, Java, and a number of other languages as well. Mongo itself is written in C++, JavaScript, and Python. But I would say that Mongo is strictly tied to JavaScript. Or you may, actually say, well, it's not really just JavaScript. It's more that they wanted to target frontend and web. I would agree. Mongo Shell is the first example. First of all, it's written in JavaScript. Second of all, it uses JavaScript. You can actually add your own JavaScript functions to extend the shell capabilities. This is actually quite nice. This is quite powerful. I like that feature. Mongo uses JSON as the, format for its data, the data exchange language. Pretty much, if you're querying Mongo, you're querying JSON object. Under the hood, to make it faster, Mongo does BSON, so binary JSON. It's a superset, but let's not get into that right now. And of course, MEAN, again, you see, front-end web tied. MEAN has, after all, Express, Angular, and Node. All right, hype. It's inevitable in a number of ways. NoSQL equals hype. Distributed equals microservices equals hype. Mongo user group talks is another way to use the hype. So Tengen, the company behind Mongo, they very quickly sponsored a number of Mongo user group across whole United States and then farther out. Why? Because at Mongo user group talks, they could kind of control the message, but then again, they also had the grassroots, facsimile, to be honest. So it's like they are seemingly grassroots, but then again, they have some control over the message that is being spread. And, if they sponsor it and they invite people come and they hear from other developers about, well, MongoDB this, MongoDB that. Blog posts. You see, number of times I have found blog posts for example, about MongoDB performance, MongoDB global logs, and they were sometimes written by people who were Mongo employees, which wasn't very clear at the time. So this also is a form of marketing, and I do think a number of those blog posts have been, since cleared up, but there's that as well. Hackathons and mean, again, this was already covered, and Mongo is incredibly easy to install. You can, with few minutes, you can get their Atlas offering. So this is Mongo in the cloud, or of course, Mongo is Dockerized. So about that hype, need I say more? So surprise, did you know that Mongo had global log crippling intense multi-thread workflows? For a database which says we are Mongo because Mongo us, so big data, this was kind of a surprise to many, this global log. And for a number of years, this wasn't really very prominently featured in the documentation. Now they have rather nice documentation saying where they have the global log, when they have database log, and when they have collection log. So there is much greater granularity, though take a look at your workflows, because perhaps you will trigger the global log. They had the save saves feature, but it was hidden and turned off. So people assumed, oh, my save, so I'm okay, safe, but well, not really, because the feature was hidden and turned off. It is prone to losing data. They sometimes even lost data during read. And if you want to know more, stay here or just head off to Jepsen analysis. And it doesn't pass Jepsen tests, unlike what they sometimes claim. So relations, that shouldn't come as a surprise that NoSQL database doesn't support relations. Still, number of people that I advised about Mongo, they were surprised by that. Doesn't offer full AC transactions, despite what it says on the tin. Well, we will get into that in a moment. The non-isolated transactions are plagued by anomalies. You can, for example, take a look at data which should be delivered in the next transaction. Why is it visible in your current transaction? Shouldn't they be like isolated or something? Unsafe defaults compromising everything for marketability until marketability decides, okay, we really need to update that. So, for example, the security disaster, I think a year ago, with 40,000 MongoDBs being taken over, ransomed, and forced them to actually decide, okay, this wasn't a very good choice, let's update the defaults. And there is one more case about the defaults I'll be talking about later. You need to actually make sure your working set, so the data that you're using the most often, fits in RAM. Otherwise, MongoDB will start crawling. So for a data which is supposed to work on a really big data, there are things you need to know. You may end up rolling back your data unless you take great pains not to. MongoDB documentation makes it seem like this is very rare. People seem to talk about this like, oh, it sometimes happens, but what are the odds? But unfortunately, the experiences of people in the real world kind of contradict that. It actually discourages Arbiter. I'm mentioning this because at some point Arbiter was another selling point of Mongo. It's no longer the case, cause sharding and other reasons. And of course, the transaction default, if you're want to use transactions, which are a very new feature, they are like 3.6, 4.4, and 5.0 have like the greatest strides made for the transactions. And transactions have those defaults which override the defaults you may have set on the database, which is kind of counterintuitive. So if you wish, oh, this transaction will work, well, it may not work. The list of surprises isn't short, and this may come off as a peculiar because I said that they have nice documentation. Well, trick is it is in the documentation if you look deeper. So one of the very common questions, very beginning questions, are quite blunt ones that I ask my customers: do you really need MongoDB? Do you even need that kind of scale? What have you tried with RDBMSs so far? Do you need active clusters? Do you need distributed transactions? Why are you after Mongo specifically? So, my name is Tomasz Borek. I have a Twitter, a blog, my own company called Mitoridafi. I'm frequently cooperating with Semantis. Here today, I'm representing EPAM. You might say EPAM is currently my main customer. And you may find me on various groups. in the internet. There are links for your, leisure. This presentation, by the way, is already present at my website. So LAC.pl, scroll down a little bit and you will find presentations, including these very slides that I'm, speaking of right now. So I do audits, I do performance security, DBs, systems, net, pretty much whatever you wish. Among my last projects, there is also one website which I'm doing for a friend. So as you can see, quite wide options. And I wanted to tell you a little bit about one project I'm doing. It's Junior Java Academy Online. So for non-junior people, this will be perhaps not very interesting, but bear with me for like 1 minute or less. November, we begin. February, we end. There will be 9 hours of lectures a week, Monday, Wednesday, Friday, from 8 till 11. The registration link is at the bottom. If you don't want to register but want to subscribe, because now is not the time, but perhaps in the future, the link at the very bottom is your pick. We look for mainly people in Krakow or Gdańsk, but the first, what you need to know, this is an online program. So even if you don't, get the job offer at the very end of it, even if you don't get it to the academy at the very end of it, you still will get a lot of knowledge and some experience. All right. There will be a moment when this slide will pop up. Don't wait for it with the questions. Feel free to, fire them away. I'll answer them a bit later in the chat. Okay, what was promised? What was offered? Let's take a look at NoSQL, CAP in Mongo, and distributed system scaling transactions in Mongo. Databases are hard. You see, we do not appreciate how much, experience there is in, say, Postgres, Oracle, and other databases, which we know, the relational databases. They had decades to get to that point. They postulated third normal form for a reason. They wanted to hold data in the databases. They have relationships. So actually, algebra, this is a branch of mathematics. They have indexes to solve performance problems because they figured that out long ago, and many, many more. I'll stop here. But what we expect when we pick up a NoSQL database is very often the same level of maturity, which is just, this just doesn't happen. Now, the other thing I want you to know is that with databases, very often, like years ago, when NoSQL movement was getting traction, databases people would say, you don't want active clusters. They would tell you a lot about how you don't want distributed transactions. Along came NoSQL, which promised just that. So what does NoSQL really mean? Take your pick. Like option 1, NoSQL, like none, nada, zilch. You do not have SQL at all. Option number 2, not only SQL, because we have polyglot persistence. So I have SQL here, but I have NoSQL over there. And I can, mix the databases how I please. Number 3, I don't actually know, the sources are confusing. I do get you, brother, I do get you. Then we have the new SQL, which is like new SQL, like, pretty much similar to number 2, but with we want to replace the SQL with what we offer. And then cynics would say, in the acidic caustic tone, no, SQL, with a comma, really loudly heard. So here is a history of databases in notation. So NoSQL. In the 70s, we had NoSQL. In the 80s, SQL was pretty much the best that we had, so we should know it. Then in the 2000s, we actually wanted NoSQL. That was the moment when the movement was at the most aggressive. And then it was not only SQL, and finally with the comma. So some people would agree. I definitely see why, SQL people would be annoyed by some of the posturing that comes from the NoSQL movement. I totally get it. The original CAP theorem divided the system. You cannot ignore partition tolerance, said the wise man. So, pretty much everybody were like, are you CA? Are you CP? Or perhaps you're even worse, CA. Oh, those bad SQL systems. Because SQL systems were actually telling that you can get consistency and availability. What Brewer was saying with the CAP theorem is that only up till certain scale. When you pass the scale, it's no longer so nice, because then if a partition happens, you cannot ignore it. So if you cannot ignore it and we have the triangle rule, then you need to sacrifice either consistency or the availability. This division has since been, reworked, revised, and quite criticized. For once, it doesn't take into account latency, which we wanted to take into account. So obviously not that great. Now, as you can see, Mongo is over here. So it is a CP system. So availability is not really the issue for Mongo. But if you take a look at Mongo documents, they say we have given availability from the very get-go. You can replicate, you have replica sets. Obviously that's availability, right? That's not consistency. So the NoSQL promise is no relational DBs or less, or we can work with them, but you have the other things. That's actually quite all right. You don't want to say, I don't know, model graph databases using SQL. That's possible, but why would you? Distributed, active. Yes, sure, NoSQL says we will do it. Scalable, in, out, up, sideways, you name it. Every single scalability in the NoSQL promise is pretty much included. And big data, like Mongo, the name, as I explained before. So pretty much they promised everything. So they promised anything, again, a little bit. So what's Mongo's promise in it? So CP, so consistency, but well, wait a few slides. Mongo is for big data because humongous, but it's also RAM limited. So this big data is possible, but you need to have the RAM for it. If you have the disk for it, you still can have it, but it will be a bit slow, very slow. Now then you have good for financial things until, one Bitcoin startup busted things, then the second Bitcoin busted, and then, the third financial company also moved away. So they also said we live in a post-transactional era, which is not really that, matching to financial things. So at first they were saying no transactions, but well, okay, so transactions, but only local, not for sharding. Oh, wait, but sharding is for big data. Okay, so, okay, transactions will work with sharding, but with limits. So as you can see, this is not maturity. This is, delivery, testing the market and scaling back. Like, okay, we said no transactions, but you didn't buy it. So we're saying, okay, transactions, but only local, and so on. So it goes. So when Mongo completes a write, you can take a look here. You have a client, and the client has several replicas. Option A, when all replicas have the data, then the write is completed. Now, take a look at, image B. Option B tells you that majority of the replicas, so perhaps not all of them, but most of them. If that's the case, then we are clear that the write is completed. And then you have option C. MongoDB, writes to at least one replica. One replica has the data, we can, move on. And none of the options are the true option, because at first Mongo completed the write before it ever left the client, which was quite surprising for many people and caused very often to, a data loss. Replication and sharding. Replication relies on having a backup copy. So pretty much this assures you won't lose data. We have a backup. Mongo may lose data in replication due to so-called rollbacks. I do agree with Jepsen. Jepsen says this is a fancy way of saying data loss. And I must say I do agree. But again, it's not that Mongo is bad. The problem is hard. You see, the relational people, they didn't deliver that for a reason, So Mongo has crazy defaults in a number of cases. There are election problems if you have, a cluster and you have election, and election is won by the server, which wasn't, the main server before, wasn't the active server before. It tells the other active server, the previous active server, roll back your data. That's pretty much, a data loss. Sharding is a technique of horizontal partitioning. That is the other thing that Mongo, is very famous for, replication and sharding, right out of the box. That's a very cool thing. So sharding is horizontal partitioning. It's good for scaling. If you use sharding, however, some things won't work in Mongo, and you will be limited in a way. It's not, that Mongo is shitty or something like it. It tackles hard problems. So distributed systems, as we already said, are hard. A distributed system, pretty much, take a look at the definition here by Leslie Lamport. A distributed system, some computer somewhere, I don't know where, I don't know if it even exists, but it crashed. And now my own computer doesn't work because we have a distributed system. I can't work just with my computer, and I can't work just with this other computer. I need both of them. And then let's take a look at the network fallacies. I do believe that a number of you already know that, and that is awesome. I encourage everybody to learn about network fallacies. We are working and living with distributed systems. We need to know that. So the network is reliable until somebody comes and, bites off the cable, even the transoceanic one. Yes, sharks do that. Then you have latency, which even the CAP theorem originally, didn't take into account. So you have this cost of, actually traveling the distance. Then you have the fact that everybody thinks like, oh, network can handle it, but can network handle it? Do you know how much it can handle? Actually, do you even know how many packages are traveling through your own network? Like in your server room, how many other applications are sending packages that use the same bandwidth that your application should rely on? So that's something quite interesting, right? Then the network is secure. As we know, it's not really secure. There are plenty of malicious actors which want to take a look at your packet, and the same defaults, insane defaults is actually a thing. The topology, we used to travel through BNC cables. Now we have fiber optics. Then it's only one administrator, and he can tell you, yes, roll it out, and you're rolling this out, and then the other admin says, why did you roll it out in the middle of firewall reconfiguration? That was a dumb idea. Who told you to do that? And you're like, well, the other admin. So didn't you ask me? Well, I didn't know you exist. Sorry, mate. So there's you go. Transport costs is again non-zero. There's no such thing as free lunch. And finally, the network is homogeneous. No, it's not. It's absolutely not. You have plenty of different devices. So no way. Active passive cluster. If you have a cluster, you have a distributed system. So add network problems, add clustering problems, because cluster is a group of servers which talk to each other in a specific manner. They need to do something, they are clustered for a reason. The logic behind this clustering brings its own problems. You have a cluster, add network problem, add clustering problems, and then your own system problems. Your system also tries to solve some problem, right? So again, it will have complexity doing that. Transactions in SQL bring with it ACID, so atomicity, atomicity, isolation, durability, and consistency. Then MVCC, which is a multi-version concurrency control protocol. And you have isolations level, which are defined in the ANSI standard. So transactions in SQL, they again took years to get to the level where they got, and we discovered problems during our journey there. And then we have active passive cluster with transactions. Now that's a mouthful, isn't it? Now cluster means distributed system, so network clustering and your own system problems. We already established that. But you also wish at transactions. Sure, so try distributed multi-version concurrency control. Try isolating your transactions, against every other transactions, and try applying them or rolling back with atomicity, which is distributed now. So you just don't have, the immediate answer which you had before. Now you need to wait for this other computer. And if it doesn't, work for a reason, like any of the network fallacy, well, tough luck, isn't it, mate? So non-zero latency, changed route, and distributed atomicity, blah. And what if you need to actually do a rollback, distributed one? You partially apply to your things, now you roll them back. Now that's not an easy thing to do, right? So you don't want active because active passive has problems, and active brings another set of problems to the equation. You suddenly have multiple concurrent and simultaneous writes. Everybody accepts writes now. It's not just one server which says, oh, I have the newest writes. Everybody has the newest writes because they come simultaneously. So do you want your transactions with that? So you can't sacrifice partition tolerance. So again, bad idea. Jepsen, fantastic piece of engineering, a tool to check if a distributed system actually handles itself like it promises. It handles itself like when partition happens, under load, etc. So shout out to Kyle here for his incredible tool and work on it. Head over to Jepsen.io and take a look at the analysis. I'll open one for the MongoDB 4.2.6, and here, guys, you have the updates, just the background. Take a look at just the background. You see all those links. These are actually links to important information. So when you'll be reading that, take a look at how much you have here. This is actually a great piece of scientific work. You have the definitions of the consistency level, you have the analysis, the links to whatever was found in the Mongo documentation, in other work by Kyle, in other work by other people, in the scientific papers explaining why this definition is not really what it should be, etc., etc. And one interesting thing, in Mongo, there are anomalies in the transactions. This particular analysis I have listed here takes just a look at the transactions because, well, Kyle was kind of provoked by Mongo treatment of his previous test. And there was this nice claim here. Oh, yes. MongoDB homepage proudly advertises full ACID transactions. The transactions page states that MongoDB is the only database that fully combines the power of the document model and the distributed systems architecture with ACID guarantees. A combination also claimed by Cosmos, Dynamo, Fauna, Oracle, Orient, Raven, SAP, Yugabyte, and others. So as you can see, this is really very good counter to marketing claims. This is why I also encourage you to, take a look at it. All right, guys, back to Jepsen. What does Jepsen do? It tests system behavior, especially when a network partition occurs. It tests partition tolerance, but it also tests what happens when the partition heals. You see, when the partition heals, then you're actually getting, a valid working network back again. But your system already worked in the split brain condition. So what happens when all the servers can talk to each other again? Well, it happens that they need to share data. They need to actually, talk about what happened. Like, oh, when you weren't there, I actually accepted 7,000 requests from users. And the other server is like, that's nothing. I accepted 7 million. And they need to, talk to each other, make that work somehow. Or they need to say, roll your changes back. That's where the devil is, right there in the details. Mongo clusters have active passives with arbiter, so replication, and active passives without arbiter, again, replications. Then you have sharding, which actually makes you sharded replica sets, so clusters per shard, one replica set for a shard. And I'm skipping config here for simplicity, we only have 40 minutes. So that's for big data and scaling. So again, coming back to when Mongo completes a write. Now the answer here is quite dependent on the default settings. Prior to, I think, 4.4 or 5.0, Mongo's default settings were pretty much sacrificing everything for speed. And thus, the speediest that you could reply to the client, yes, your data is saved, is before it even leaves the client, or as soon as it just gets to the active server in your cluster. Mongo calls it primary. And then that's pretty much your thing. And right now, take a look at your default when you're choosing Mongo, all default settings. So if partition happened when you were trying to get that write saved, what actually does it mean? If you don't have the majority in your cluster, what happens? And what if primary went down and then it healed when the election was still ongoing, or it healed right after the election was finished and the new primary was elected? What if partition healed, showing the other part of the network, and they also elected the primary? So we have two primaries. So as you can see, guys, this isn't really simple. And I do encourage you to take a look at Jepsen's analysis to get number of answers for questions like that. Moment for you to write something in the chat. We're ending the talk, summarizing first. MongoDB is nice. The marketing promises the sky and beyond. It is very popular. Many have failed actually, but they scarcely left a dent on Mongo sites and its materials. They don't mention the largest failures. So be very, very careful. It must be said that NoSQL movement actually overpromised. Distributed systems are very hard. Transactions are hard. Distribution system with transactions get progressively harder. RDBMS makers didn't want to do active clusters, distributed transactions for a reason. NoSQL is not very well defined. Some definitions tell that it's different than others. So definitely too much have been promised, but still NoSQL fills a very nice niche and gets you quite simple results for quite simple problems. Even in hard problems, you can still use NoSQL and get what you wanted. CAP theorem has been revised since its inception. Take a look at the new literature, because the original division has been too strict, and no latency, come on people. So if you're choosing Mongo or hearing about somebody choosing Mongo, warning should, light up your entire brain. MongoDB promises to be good for all use cases. Not true. Read the small print in their docs, go deeper into their documentation. Then you will find actually quite worthwhile information. Well, not saying that the early shallow surface is not worthwhile. It is, but if you want to use Mongo, not, administer it or keep your crucial mission critical data in it, read, understand Jepsen analysis, do your own tests or pay Jepsen to do the tests for you. I'm quite sure Kyle won't mind. Consider unusable scenarios, like when will you do things which Mongo doesn't support? NoSQL is now not only SQL, at least to most sources. Consider scenarios, chosen technology. CAP theorem was revised. Are you even big data? Because perhaps you're not, then just screw this. And replication is difficult. Do you need the active replication? Yes, I'm sure it sounds absolutely lovely marketing-wise, but are you really ready for the fallout, for all those little problems that you will have? Are your networks also good enough to have that? Sharding, even more so. Then we have distributed transactions, hard, dangerous. Silver lining, though, in all of that is we do move forward. NoSQLs are getting much better. Version 5.0 is much better than 2.0. You do need to read the fine print. You do need to have lots of tests, but just use this talk. No, I will never use MongoDB. Rather as idea generator. If I use the MongoDB, then I need to take a look at this, and that. And each time Jepsen, launches the tests, take a look, because Mongo actually quite nicely responds to that. Well, they could do better, but it's already not bad. So thank you. TJB out. I'll gladly take, any sort of badges for people from EPAM, and emails and chats and whatnot with remarks and feedback. So please, thank you. And I'm passing the voice back to the studio.